Let's talk about ionic bonding in much more depth. In the previous video, we talked about the basic fundamentals of how ionic bonds get made in sodium chloride. Now, I want to look at why and how these steps happen during the formation of ionic bonds. In order to really understand what's going on in ionic bonding, we have to take a look at the individual electrons that live in sodium and live in chlorine. Now, as you probably know, there are specific places in an atom where electrons can live. Okay, I have a diagram of this here. If this is new, you should check out my video called Valence Electrons and the Periodic Table. Anyway, each one of these little circles represents a spot that an electron can live in an atom. And you'll see that these little electron spots are arranged in rings around the nucleus of the atom. Each one of these rings is called a shell or an energy level. Okay? So we can use this diagram to figure out where the electrons live in sodium and where they live in chlorine. Okay? First thing we got to do is we got to find out how many electrons there are in these two atoms. Okay. Now, sodium here, you look it up on the periodic table, it's got this 11 here. That means it has an atomic number of 11. There are 11 protons in sodium. Now remember, when ionic bonding starts, these atoms are not yet ions. They don't have a charge. They're neutral. So that means that they have the same number of protons and electrons. So there are 11 protons in a sodium atom. That means there are also 11 electrons in a sodium atom. Okay, the same thing is true with chlorine. It has an atomic number of 17 protons. It's starting out without a charge, so it has 17 protons and 17 electrons. Now, we can take one of these diagrams and fill it in from the center on out with a number of electrons. So, for sodium, that's going to look like this. 11 electrons arranged around the atom from the center out. And for chlorine, it's going to look like this. 17 electrons arranged around this from the center out. Now, you may not be able to tell from these diagrams, but these are two very unhappy atoms. The reason why has to do with their valence shells. You remember what valence shells are? They are the furthest out energy level that still has electrons in it. Okay, so for example, this is the valence shell of sodium. It's got one electron here. And this is the valence shell, the furthest out shell for chlorine. Okay? The reason why these two atoms are so pissed off is because every atom wants to have a full valence shell. It's like every atom's goal in life. Sodium is really unhappy because it only has one electron in its valence shell, and it has these 7 empty spots. Okay? Chlorine, on the other hand, is also upset because it's got a mostly full valence shell, but it's got one empty spot. It's so close. It's so close, but it's still super unhappy because the valence shell isn't full. So sodium and chlorine are both unhappy. They both want to fix their situation. And in trying to fix it, that is how they're going to end up with an ionic bond. Okay, so how are sodium and chlorine going to get happier? How are they going to fix their situation? How are they going to try to fill their valence shells? Well, take a look at this. They can help each other out, okay? Chlorine has one spot left before it's able to fill its valence shell. And so what happens is sodium can give chlorine one of its electrons, okay? So this electron moves from sodium to chlorine to fill this spot. Here's what we end up with. Okay, let me just show you what's going on here. Okay, so we got sodium, we got chlorine, and this electron up here moves between them. Okay, so it leaves sodium and it goes into chlorine. Okay, and now chlorine has filled this empty spot with one of sodium's electrons. Okay, so now chlorine is super happy. It has a full valence shell. It's achieved its goal in life. But take a look at sodium over here. Though you may not know it, sodium has also achieved its goal in life. Because when it gave this one electron, when it gave the electron to chlorine, it totally emptied out this valence shell. Now you might think, okay, that made it even worse because now it has 8 empty spots it has to fill. But here's the thing. If you can get rid of all of the electrons in your valence shell, it's like that valence shell just disappears. Sodium doesn't even have to worry about it anymore. Okay, so it gave away this last electron in its valence shell, and now it's like the valence shell just disappears. And this is now sodium's new valence shell, and check it out. It's totally full. So by giving away that one electron, it could get rid of its whole outer shell, and this is its new valence shell. It's full, and sodium's happy. So this is what we end up with. Let me just show you what the intermediate steps look like here. And this is what it looks like when sodium gave it away, and we can sort of think about it still having this outer shell. And here is chlorine with the new electron from sodium. So we've got step 1, step 2, step 3. Okay, so now chlorine has a full valence shell. Now sodium got rid of its old valence shell, and its new valence shell is totally full. They're happy. But let's talk about what's going on with the electrons here, okay? Because there are electrons moving. Now, over here with chlorine, it used to have 17 electrons, and then it got a new electron from sodium. So it doesn't have 17 electrons anymore. Now it has an extra one, so it has 18 electrons. But it has the same number of protons because we weren't moving protons in this example. Okay? So it's still got 17 protons, and it's got 18 electrons. But now there's an imbalance between the number of protons and electrons. It doesn't have the same number of protons and electrons anymore. It has more electrons, which means that it has a negative charge. It has a negative charge of 1 minus because it has one more electron that it got from sodium. And now we can call it an ion. Now, sodium also became an ion, right? It used to have 11 protons and 11 electrons, the same amount, so it used to be neutral. But not anymore, because it gave away one of those electrons, so now it only has 10. But it's still got the same number of protons. It's got 11 protons with positive charge, and it's got more protons and electrons. One more proton. And that means it's going to have a positive charge, okay? It's going to have a 1 plus net charge, and it also is going to be an ion, an atom with a charge. So this guy over here has a 1 minus charge. This guy over here has a 1 plus charge. Now, as we've said before, they have opposite charges, so we could maybe kind of zoom out a little bit. Take a look at what these atoms are going to look like. Here we've got a chloride with a negative charge. We've got sodium with a positive charge, and they're going to stick together, just like we've shown here. And that is because opposite charges attract. We have the positively charged sodium attaching with a negatively charged chlorine, and that's going to give us sodium chloride. Sodium chloride. Now, the formation of ionic bonds is one of the trickiest concepts in all of chemistry. So many people are confused by it. So I just want to go through this one more time, really quick, step by step. Okay, so we start out with sodium and chlorine. They are both neutral. They have the same number of protons and electrons. But they're both unhappy because their valence shells are not full. Chlorine has an empty spot, and sodium has only 1 electron in its valence shell. So the electron here moves from sodium to chlorine. Okay, so now chlorine has 1 more. It has a full valence shell, and it's happy. Sodium empties out its valence shell, so it's almost like that old valence shell just disappears. We end up with this, and the new valence shell is totally full. So now sodium and chlorine are both able to get full valence shells. But electrons had to move in this process. So now sodium has 1 fewer electron than proton, so it gets a 1 plus charge. Chlorine got 1 more electron, so it has 1 more electron than proton, so it has a 1 minus charge. So these guys, they trade electrons, or an electron moves from sodium to chlorine, in order for them to get full valence shells. And it's in the process of that happening that they end up getting charges. As I said, this is one of the most complex topics in chemistry. People have so much trouble with it. So I urge you to maybe check out this video again, watch it from the beginning, make sure you really understand it before you move on. And once you're good with this stuff, go on to the next video.